Hi grade 9s and welcome again to WorksheetCloud Maths. So nice to be with you again. Today we're going to carry on with our series on surface area and volume, and let's see what we have for you today. Okay, so it's our fourth lesson in this series, and we're going to look at how to work out the missing units, which we've touched on in our last lessons, but let's just see how we'd go. Okay, so you are given the diameter of 76 centimeters and the height is 108 centimeters. So we're still working with the cylinder, but now we need to work out the surface area of this cylinder that these measurements belong to. Okay, so we are given the diameter, we were used to working with the radius, and we are given the height. So let's see what we need to do. Okay. First of all, our radius would be half of the diameter. So all we do is we take 76 and divide it by 2, find half of it, and that would give us a radius of 38. Now we've got our radius and we've got our height, and we need to work out our surface area. So remember, when we're working out the surface area of a cylinder, we've got to work out the surface area of the top circular base and then multiply it by 2 to get both bases, and then times it by then we have to work out the surface area of the rectangle from in the middle, and then we can add it all together. Okay, so let's look at the formula. We've got surface area is equal to 2 times pi r squared. Remember, our pi r squared is going to give us the area of the top circular base, or one circular base, and then we've got to double it. And then our area of our rectangular shape in the middle is going to be 2 pi r times height, okay? Because remember, the 2 pi r would be the circumference of that circular base, and that would actually be the long side of the rectangle. Okay, so let's plug in what we've got. We've got 3,14 is pi times our 38 centimeters that need to be squared, because remember, that's the radius that we've worked out. Then for the rectangular shape of the cylinder, it's 2 times 3,4, which is pi, times 38 centimeters times 108 centimeters, which is the height. Okay, so we're going to go 38 squared is going to give me 1,444 centimeters squared. Remember to use your calculator, guys, otherwise it's going to take you so long to work this out. Okay, we're going to then times that by 3,14 and then double it. But in our next bracket, which is to do with the rectangle, we're going to go 2 times 3,14, which by now you should know is 6,28, and then 38 times 108, and it's going to give me 4,104 centimeters squared. Okay, so let's times out the brackets. We've got 3,14 times 1,444. We're going to end up with 4,534,16 centimeters squared. Remember, that would be the area of one of the circular bases. We've now got to double that. That's why that times 2 is there. Okay, then our 6,28 times 4,104 is going to give me 25,773,12 centimeters squared. Work out the first bracket. You're going to end up with 9,068,32 centimeters squared, and you still have to add that to your 25,773,12 centimeters squared. Right? Add those together, you end up with an answer of 34,841,44 centimeters squared, and that would be your surface area. Okay, so here we weren't given the radius, we were given the diameter, so we had to work out the radius, and from there we can then work out the surface area. Right, let's look at the next one. Okay, here you are given the volume of the cylinder, which is 10,857 centimeters cubed, and the radius is 1,2 centimeters. So now we need to work out the height of the cylinder that these measurements belong to. Okay, so we're given the radius, we don't have to worry about trying to change a diameter to a radius measurement, but all we will do is we will take our volume formula and we will plug in what we know and then use our algebra knowledge to work out what we don't know. So we know the volume is 10,857 centimeters cubed. We know what pi is, which is 3,14, and we know that the radius is 1,2 centimeters that we have to square. Okay, we then have to leave it as times h because we don't know what the height is. That's what we are trying to figure out. Okay, so let's work out what's in the bracket first. We have to square our 1,2 and it's going to give us 1,44 centimeters squared. We then are going to have to multiply that by 3,14 and we end up with 4,5216 centimeters squared times the height. And we were told right in the beginning that the volume was 10,857. So all you now do, because this is multiply, is that you have to divide this side by that number, and therefore you have to divide that side by the same number. You're going to end up with 10,857 centimeters cubed over 4,5216 centimeters squared. Okay, because it's centimeters squared at the bottom and centimeters cubed at the top, you're going to end up with just centimeters because you would cancel that out. And then with the numbers, use your calculator. And you end up with 2,401 centimeters, and that is your height. Okay, if you are told to round off, which very often you are told in these calculations to round off, and you're told to round off to the nearest decimal place, the first decimal place, it would be 2,4, because obviously the naught tells you that you don't change the 4. If you need to round up to the nearest whole number, your answer would be 2 centimeters, because 4 is less than 5. Okay, everybody happy so far? Right, let's move on and look at this one. I want you to try it. There is the problem. You are given the volume again and the height again. Now you need to work out the surface area of the cylinder with these measurements. Okay, so pause the video. You try and work it out. Your calculations might be quite long, but that's all right. When you are finished, then come back and we can go over it together. Right, let's see how you did. Okay, so we don't know what the radius is, but we can work out the radius by using the volume because we've been given the volume. So we're probably going to use both our formula today, or in this one, to work out the volume first, or the radius first from knowing the volume, and then to plug it into the surface area formula. Okay, so our volume is 15,607 centimeters cubed. We know that pi is 3,14. We don't know what the radius is, but we do know what the height is, and that's 3,45. So what do? We go 5,607 centimeters cubed on the one side, because that's the volume. We then say 3,14, which is pi, times by the height, which is 3,45, and we get 10,833 centimeters, and that is going to give us the radius squared. So what do? We will divide both sides by 10,833, like that. And that is going to, like I said just now, give us the radius squared. Okay, so 1,441 centimeters, should be centimeters squared there, sorry, would be radius squared, but we need to now square root that 1,441, and it ends up with 1,2 centimeters is the radius. Okay, please don't make the silly mistake that I did. There should be a square sign there. Alright, so now we've got the radius. We're not finished with this calculation because we were asked to work out the surface area. So there is our surface area formula. Let's plug in. Okay, we've got our 2 times pi r squared, our 1,2 that we worked out here is the radius. So we've got to square that and then multiply it by pi and then double it. Remember, as I said just now, because that would give us one circular base, just the pi r squared, and then we've got to double it because we've got 2 circular bases in our cylinder. Okay, so then we go to our rectangular part of the shape, and it would be 2 times 3,14 times the radius, which is 1,2, times the height, which is 3,45. Okay, let's multiply out. We're going to end up getting 1,2 times 1,2 is 1,44. And then on this side, we would go 2 times 3,14, which we've done so many times before, gives us 6,28. 1,2 times 3,45 is going to give us 4,14 centimeters squared. Okay, so now we're going to times the 1,44 by the 3,14, which is pi. You're going to end up with 4,522 centimeters squared, and you've got to double that. And then we multiply that out and we get 25,999 centimeters squared. Okay, doubling the 4,522, you're going to get 9,044 centimeters squared. plus 25,999 centimeters squared. Because they are like terms, just add them together and your answer is 35,043 centimeters squared. Did you all get that? If you didn't, remember, go right back to the beginning of you try this one and then play the video again and you will see the explanation. Just remember that that should have been squared. Okay, right. Now, before we go on, there's some conversions that we need to look at. So, what is the difference between volume and capacity? Well, volume is the amount of space that something takes up, and the capacity is the amount that something holds. So let's see. Volume is the amount of space occupied by the object and is measured in units cubed or cubic units, whichever way around you want to pronounce it. It's fine, it's the same thing. For example, meters cubed, centimeters cubed, millimeters cubed, which is what we've been working with. Okay? But capacity is the amount that the object can hold, and it is measured in kiloliters, liters, and milliliters. So in other words, if you think of a Coke bottle, the amount of space that it takes up would be its volume, but what's inside it is its capacity. So very often when we look at things in the shop, we won't see the cubic meters, we will actually see the liters, the milliliters, or sometimes it goes by weight. Okay, so but the capacity is what would be inside the object, and the volume is the amount of space that the object takes up. All right, but we need to remember this. 1 milliliter is the same as 1 centimeter cubed. 1 liter is 1,000 milliliters. We know that because of the conversion on our chart with our milliliters and liters. There are 1,000 milliliters that make up a liter. Okay, but if we've got 1 milliliter is equal to 1 cubed centimeter, then 1,000 milliliters is equal to 1,000 centimeters cubed, which means that 1 liter is equal to 1,000 centimeters cubed. Everybody got that? Let's just have a look again. 1 milliliter is the same as 1 centimeter cubed, but we know that 1 milliliter is 1,000 milliliters is 1 liter. Okay, but 1,000 milliliters would give me 1,000 centimeters cubed. Therefore, 1 liter is 1,000 centimeters cubed. Okay, therefore 1 kiloliter is 1,000 liters, and 1,000 liters would give me 1 meter cubed. Okay, so we need to remember that going forward because we've got some conversions to do now, and then we've got some problems to solve later. Okay, so convert these. There we have our conversion table, and there is what we've just discussed now. 1 milliliter is 1 centimeter cubed. 1 liter is 1,000 milliliters, which is 1,000 centimeters cubed, and 1 kiloliter is 1,000 liters, which is 1 meter cubed. Okay, so if we've got 150 centimeters cubed, how many milliliters would that be? 23,500 centimeters cubed, how many liters, etc., etc. So let's try and convert those, remembering these conversions. All right, let's have a look. We've got 150 centimeters cubed, and we had to convert that to milliliters, and remember 1 centimeter cubed is 1 milliliter, so 150 centimeters cubed would give me 150 milliliters. Okay, 23,500 centimeters cubed, how many liters? We would go here, so to get from centimeters cubed to liters, we would divide by 1,000, divide that by 1,000, your comma is going to go there, so it's 23,5 liters. Here we've got meters cubed, okay, 13 meters cubed. We had to get to liters, so here we're going to go from 13 meters cubed to liters. We're going to times by 1,000, so it's 13,000 liters. Okay, 5 centimeter cubed, we had to get to liters. 5 centimeters cubed, we're going to divide by 1,000 to get to our liters. Look here, here's our cubes. Centimeter cubed here, it's 1,000 equals 1 liter, which means we're dividing by 1,000. So that would end up being 0,005 liters. And then 1,245 meter cubed, 2 kiloliters would be exactly the same. Okay, because 1 is to 1. All right, we now have got 14 kiloliters. Okay, that would give us 14,000 centimeters cubed. okay, because we're going from kiloliters to centimeters cubed. And that's 1,000 difference, so it would be times by 1,000. Okay, the next one, 45 liters to meters cubed. It would say the same. Have a look here. Kiloliters, 1 kiloliter is the same as 1 meter. Sorry guys, I just fixed that for us because it should be 14,000 centimeters cubed. If you have a look here, we've got kiloliters going to centimeters. We're going to actually have to times by 1,000, right? And then 45 liters, sorry, this was the one that was the incorrect one, is 45,000 meters cubed. Okay, again, you look here, you've got 1 liter, if we're going down here, 1,000 liters would give you 1 meter cubed, and we were converting from our liters to meters cubed, which means we have to times by 1,000. So we end up with then here 203 liters going to centimeters cubed. We have to times by 1,000 again, and we're going to get 203,000 centimeters cubed. Okay, right, now let's have a look. Here's a problem to solve. Okay, Tembi wants to collect rainwater from her roof so that she can water her garden. Okay, not an unusual problem. A lot of people do this. But the hardware store sells 2 types of sealed tanks. The one has a circular base with a diameter of 80 centimeters and a height of 1,6 meters. The other has a square base with a side of 80 centimeters and a height of 1,3 meters. Okay, so the first thing to do, there's 3 things we have to work out. First of all, we have to work out which container has the larger volume. Obviously, she wants to know which container is going to hold the most because she wants to collect the most rainwater. Then we have to work out how many liters each container will hold, and we need to round that off to the nearest whole number. And then we need to work out which tank would be cheaper to paint, and we need to explain that. Okay, so the first thing that I think we should do is we should draw a representation of each tank, just so that we've got it in our mind what it actually looks like. So there we go. Our first tank is a circular tank. It's got a circular base, and it tells us that it's got a diameter of 80 centimeters and it's got a height of 1,6 meters. Okay, so we've drawn the diagram. We can sort of picture it. The next one, we need to draw the tank with the square base, and it has a side of 80 centimeters. Remember, it's square, so 80 by 80 by 80 by 80. And then our height is 1,3 meters. Okay, once we've got that picture in our mind, it is so much easier to try and work out and try and calculate. Right, so there we have our pictures. We're going to keep them in the corner there so that we can actually refer to them the whole time. Again, here's our problem. So she's got the option of one of these 2 from the hardware store, and we now have to work out which one has the larger volume. So we know what our formula for volume is. For the circular base, it will be pi r squared times height. So let's work with that one first. So we're working with this here. Okay, so we're going to plug in what we know. We don't know the volume. We're trying to work it out. We do know what pi is, which is 3,4. We know that our radius is 40 centimeters because it would be half the diameter, and we are told here that the diameter is 80. Please be careful for little things like this when you're having to solve problems, because very often we just go headlong into it and then we put that as our radius, and meantime that is the diameter that we have to halve. Okay, so it will be 40 centimeters squared times our height, which is 160 centimeters. Again, guys, that's 1,6 meters. We have to convert that to centimeters because we want all our measurements to be the same unit. So if we had worked with 1,6 meters, it would have been a problem when we were trying to multiply together. Okay, so 160 centimeters is the same as 1,6 meters. We first of all have to square our 40 centimeters, which will give me 1,600 centimeters squared. And then I can just multiply the whole lot out. Use your calculator, multiply out, and you're going to end up with 524 times 160, but you could have done it in one go and got 803,840 centimeters cubed. Remember, centimeters squared times centimeters gives me centimeters cubed. Right, quite a big number, but remember that is in centimeters cubed, and we are working with volume, so that's okay for now. Okay, the square base one, that is our formula for volume. It's length times breadth times height. So that's quite easy to work out because our length and our breadth is the same. So it's 80 times 130. Again, here at 1,3 meters, we've got to multiply that by 100 to get to centimeters. So it'll be 130 centimeters. So 80 times 80 is 6,400 centimeters squared times 130. We're going to get 832,000 centimeters cubed. Okay, centimeters squared again times centimeters is going to give me centimeters cubed. Right, so which one has the bigger volume? Obviously, the square base tank has the larger volume. Everybody happy? Right, let's go on to the next one. The next one was how many liters will each container hold, and round that off to the nearest whole number. Okay, so we had our, we need to first of all remember our conversion table, and we've got our circular base as being 803,840 centimeters cubed. Okay, we've got to divide that by 1,000 to give us our liters. Remember, we're going backwards now. There we go, divided by 1,000. It's going to give me 803,804 liters, but it did say round off to the nearest whole number. So we're going to look at the 8, and rounding it off, it's going to be 804 liters. So the circular base one tank holds 804 liters. Let's have a look at the square base. We've got 832,000 centimeters cubed. We're going to divide that by 1,000, and we're going to end up with 832 liters. That is rounded off already. It is to the closest whole number. There were no decimal points. Sorry, I'm getting a bit tongue-tied here. So it's 832 liters. Again, it stands out that the square base tank holds more than the circular base. Right, let's look at the last one that we have to work out. Which tank would be cheaper to paint? Well, here, obviously, we're going to paint the whole of the outside of the tank. And so we would have to work out the surface area for each one. So our circular base, let's work out the surface area. We've got 2 times pi r squared plus 2 pi r times height. We've been working with that for quite a while. So let's plug in everything. We're going to get 2 times 3,4, which is pi, times 40 centimeters squared first. And then we've got to add that 2 times 3,14, which we know is 6,28, times 40 times 160. Okay, so here we're going to get 1,600 centimeters squared. And here we've got 6,8, as I said just now, and 6, sorry, I'm sure this is wrong. Just corrected that for us. So it's 6,28 times 6,400, because it's the 400 centimeters times the 40 centimeters, sorry, times the 160 centimeters. So it's 6,400 centimeters squared. So when we multiply those out, we're going to end up with 3,14 times 1,600, which is 5,024 centimeters squared. And remember, we have to double it because it's the top part and the underneath part. And then add it to our rectangular portion of the tank, which is 6,28 times 6,400 centimeters squared. We're going to end up with 40,192 centimeters squared. So our bases are going to together give us 10,048 centimeters squared. Add it to our rectangular area, and together they're going to give us 50,240 centimeters squared. So that is the surface area that she's going to have to paint. Right, let's work out the surface area of our square-based tank, and it's going to be 2 times side, which is going to give us that area. So side times side will give us the top area. We have to double it for the bottom area. And then, because each rectangle going around is exactly the same size, and there are 4 of them, we can say 4 times the side times height. Okay, so we've got here side times side is 80 times 80, and here it's 80 times 130, and then you're going to times it by 4. Okay, so we're going to get 80 times 80 is 6,400 centimeters squared, and 80 times 130 would be 10,400 centimeters squared. So that answer you're going to times by 4 because there are 4 sides to our square base tank, and here we're going to times by 2 because there is a top and a bottom. Right, so 2 times 6,400 will give me 12,800, and 4 times 10,400 is going to give me 41,600 centimeters squared. We add those two together, we're going to get 54,400 centimeters squared. So which one is going to be cheaper to paint? It's going to be the circular based one this time. That's going to be cheaper to paint. Why? Because it's got a smaller surface area. So that would be your explanation, because this has a smaller surface area. So if we were to try and decide which tank Tembi would buy, it would be a toss-up to see whether she wanted a pretty looking tank to paint it well and paint it in a cheaper way, or whether she wanted the one to hold more than the other one. So the one that would hold more, remember, is the square base tank, but that's going to cost a little bit more to paint. Or she could just leave it as is if she was happy with that, or if she wanted it to look pretty, she would probably have to buy that tank because she would save money in painting it. Okay, so it would be up to Tembi actually which one she wanted to buy. Right, guys, thank you so much for listening to today's lesson. Remember that there is an activity that is attached, and if there's anything that you wanted to if there's anything that you want to comment about today's lesson, please don't forget to email grade9@worksheetcloud.com. Also, if you want to ask a question, send your question to the same email address. If you get a little bit confused on your conversions from liters and centimeters cubed, go back and watch the video again, especially the part where we did the conversion table. All right, thank you guys for listening, and I'll see you next time. Bye-bye for now.